Assalamu alaikum. Welcome grade 11 students, and in this lesson we will carry on talking about activity 1, the karyotyping technique. At the end of this video you will be able to deduce that different species have different karyotypes, to compare karyotypes, to recognize the causes of having abnormal karyotype, and to notice the importance of karyotype. Please make sure to prepare the extra worksheet and a pencil case. Previously, you've learned about the karyotyping technique and the criteria upon which chromosomes are arranged in a karyotype, where you have two types, homologous autosomal chromosomes and gonosomal chromosomes XX or XY. For this lesson, we need you to answer two questions. Is this karyotype similar in all species? And is it related to abnormalities found in certain individuals? Let's start by comparing the chromosomal number in different species as shown in the following table. What can you deduce? Do they have equal or different number of chromosomes? Well, both cases are found here, where different species might have different or same number of chromosomes. Different as in the case of the mouse and rat and the pea and the onion. They all have different number of chromosomes. And same as in the case of the rat and the monkey, as shown here. Both species have a total of 42 chromosomes. So, how do both rat and monkey have the same chromosomal number but are so much different? Can you suggest an explanation for this problem? To find the answer, it's not enough to just look at the chromosomes in this karyotype. We need to zoom into each chromosome in order to find what's the difference. Given the following two chromosomes, number 1 in both rat and monkey, what can you see here? What's the difference? When checking both chromosomes, you can find that they are very different. The genetic information held by chromosome number 1 in a rat is different from that in the monkey. Here, we've solved the first problem. Let's start with the second question. What is the importance of the karyotyping technique? To do so, please prepare worksheet 4. As you've read in the worksheet, you have 3 cases to study here. The case of normal individual and 2 cases having abnormalities, Down syndrome and Turner syndrome. And as you've read, a syndrome is a kind of chronic disease. It's found with the individual from birth. It cannot be cured. Let's start answering the first 3 questions concerning individual A. Explain why individual A has a normal karyotype. It's obvious that this karyotype is normal because this individual has a total number of 46 chromosomes, 22 pairs that are autosomal, and we have the XX pair which are gonosomal. Since we have XX chromosomes, then this individual's gender is female. Give the importance of using the karyotype of individual A. Having a normal karyotype here is important in order to compare it and find the abnormality in Down syndrome and Turner syndrome. That's why we say that individual A represents a control case, used to compare its karyotype to the abnormal ones. Let's continue on with studying the number of autosomes, gonosomes, and the total number of chromosomes in each individual. Count each chromosome individually and you can find that the number of autosomes in individual A is 44, B 45, C 44. For the gonosomes here, you can find that individual A has XX, so 2, individual B has 2 also, while individual C has 1 gonosome. The total number of chromosomes here will be 46 to 47 to 45. Now, let's compare these values in order to find the abnormalities in B and C, starting by comparing the number of autosomes between A and B. You can find here that the number of autosomes in individual B are greater or more than that in individual A. So we can say that the cause of syndrome here in B is that it has an excess in the number of chromosomes. We have an extra chromosome. However, by comparing the number of gonosomes between A and C, you can find that C has only 1 gonosome. So the number of gonosomes is less by 1. So C is abnormal because there's an absence of a chromosome. I need to remind you here, when you're comparing two numbers, you need to use the terms more than, greater than, or less than, and you need to show the values in order to have a total correct answer. So let's continue here. We found out that we have some kind of abnormality. Here, we need to explain the following terms: trisomy, tetrasomy, and monosomy. Each type of abnormality refers to its name. Tri, so we have 3 chromosomes. An extra chromosome, they should be 2. When we say tetra, it's a condition where we have 2 extra chromosomes. They must be 2, but they are 4, so tetra. Monosomy also is a condition where we have only 1 chromosome, so we lack the homologous pair here. So these 3 abnormalities are related to the number of chromosomes. If we have 1 extra or we lack 1 chromosome, we have an abnormality. However, there's another case to study here. Check out this karyotype. When counting the number of chromosomes, you can find that the number of chromosomes here is normal. There is no difference. However, check chromosome number 5. What's wrong here? We said in the previous lesson that homologous chromosomes should have same size. However, the pair 5, 1 chromosome is shorter than the other. So the abnormality here is in the shape, not in the number. So let's solve number 8 and define an abnormal karyotype. In an abnormal karyotype, you might have abnormality in the number, an excess or lack of chromosomes, or you might have an abnormality in the shape, as shown in this case. Can you now answer our initial question? What is the importance of the karyotyping technique? Well, here, with looking at this karyotype, you can find that this karyotype is important in order to determine whether the living thing suffers from chromosomal abnormalities, whether in shape or number of chromosomes, and also this karyotype helps us to find the gender of the individual, whether it's male or female. In this video, we've answered 2 questions, one concerning the karyotypes of different species and the other concerning abnormalities. So to sum up, we learned that different species might have the same number of chromosomes in their cells. The genetic information held by the chromosomes vary from one species to another. A karyotype is said to be abnormal if it presents an abnormal number or shape of chromosomes. The karyotype helps in determining the gender, sex of a living thing and shows whether this living thing suffers from chromosomal abnormalities. As an assignment, please make sure to memorize the summary sheet. This video is prepared and recorded by teacher Zahra Shiri and supervised by teacher Ihsan Hassan. Thank you for your time.